All right, let's dive in. Today, we're taking a high-level tour of one of the most powerful and influential programming languages out there, C++. We're basically creating a roadmap, one that's going to guide you from the very first concepts all the way to what the pros use every day. Let's get to it.
Seriously, just think about it for a second. You know, the incredible graphics in a massive open-world game, or how your photo editor can apply a complex filter in an instant. How does that even happen? What's the magic going on behind the screen?
Well, for a whole lot of those things, the answer is C++. It has been for decades. It's the engine under the hood for pretty much any application where raw speed and having direct control over the computer's hardware are just non-negotiable. It's a language for builders, for people who need every last drop of performance.
So, here's our roadmap for this journey. First, we'll cover what C++ even is. Then we'll get into the basic building blocks. After that, we'll see how to make our code smart and how to organize it. And then, the really fun stuff, unlocking its superpower with something called OOP. And finally, we'll take a peek inside the advanced toolkit the pros use.
So first things first, what exactly is C++? Well, in a nutshell, it's what's known as a general-purpose language. It's famous for its performance, its efficiency, and the fine-grained control it gives you over the computer's memory and resources. It's a direct descendant of the legendary C language, but it's packed with a whole lot more features.
Okay, any big journey starts with that first step, right? For C++, that means getting a handle on its fundamental grammar, the absolute core essentials you need to know to write even the simplest program.
You know, just like any human language, C++ has a set of rules. We call this its syntax. It's the programming equivalent of grammar and punctuation. You have to get the syntax right because it's the only way the computer can understand exactly what you're telling it to do.
So let's quickly break down these core pieces. Think of variables as just labeled boxes where you can store your data. Data types tell you what kind of stuff can go in each box. Is it a whole number, a decimal, or maybe some text? Operators are your action symbols, plus, minus, times, divide. And comments? They're just notes for yourself or other programmers. The computer completely ignores them, but they are absolutely essential for understanding complex code.
All right, once you know the basic words and grammar, the next step is to start forming intelligent thoughts. In programming, we call this control flow. It's how we make our programs actually smart by giving them the ability to make decisions and to repeat actions automatically. So, a program's most basic bit of intelligence is making a choice. C++ gives you a couple of main tools for this. You've got if-else, which is your classic fork in the road. Is this condition true? Yes or no? But then you have switch case, which is more like a four-way stop. It's perfect for when you have one variable that could be one of several different options. But what about doing things over and over again? That's where loops come in, and they are a programmer's best friend. Instead of writing the same line of code 100 times, you just tell the computer to repeat it. And they all kind of follow the same pattern. You set up a counter, you check if you should keep going, you do the thing, and then you update the counter and do it all again. It is incredibly efficient.
Okay, so as our programs start to grow, just having a bunch of variables and loops isn't going to cut it. We'd end up with a complete mess. So the next critical skill is learning how to organize both our code and our data in a way that actually makes sense.
And C++ gives us some fantastic tools for this. Arrays are basically like simple numbered lists. Pointers. Now, these are a little more advanced, but they're super important. A pointer doesn't hold data itself, it holds the memory address of where the data is stored. This is one of the keys to C++'s power, giving you direct control over memory. And then you have structures, which let you create your own custom data types, kind of like a digital contact card that groups a name, a phone number, and an address all into one neat package.
Now, for organizing our actions, we have functions. A function is basically a reusable mini-program. You write a block of code to do one specific thing, you give it a name, and then you can just call that name whenever you need that job done. It keeps your code super clean and avoids repetition. But as projects get really big, even this isn't quite enough. You start to lose track of which functions are supposed to work with which data. We need an even better way to bundle things together.
And that brings us to the idea that truly makes C++ a powerhouse for building huge, complex software. We're about to move beyond just writing lists of instructions and start thinking in a completely new way about how our code is structured.
And that new way is called object-oriented programming, or OOP for short. Now, this is a real game changer. The core idea is this. Instead of having your data in one place and all your functions in another, OOP lets us model things from the real world as objects. An object bundles its own data and the functions that operate on that data together into one self-contained unit. It's like graduating from building with individual bricks to building with sophisticated custom Lego pieces.
The first big idea in OOP is encapsulation. This is all about that bundling idea. We create a blueprint for an object called a class, which bundles the data, or attributes, and the functions, or methods, together. The key benefit here is protection. The object's internal data is kept private, hidden from the outside world. The only way to change it is by using that object's own methods. This is huge because it prevents other parts of the code from accidentally messing things up.
Next up is inheritance. This is an incredibly powerful concept for reusing code. It lets you create a general parent class, like say vehicle, which has properties like speed and color. Then you can create more specific child classes, like car or motorcycle, that automatically inherit everything from vehicle, but can also add their own unique things like number of doors. You're not constantly reinventing the wheel. You're building on what you already have.
And the third pillar is polymorphism, which is a fancy word that just means many forms. This is what makes OOP so flexible. Imagine you tell a car object and a person object both to move. The car will drive and the person will walk. They both understand the command move, but they respond in their own unique, appropriate way. This allows us to write really dynamic and adaptable code.
Wow. Okay, we have covered a ton of ground, but the journey isn't over. To be a truly effective C++ developer, you don't build everything from scratch. You rely on a powerful set of pre-built, optimized tools. Welcome to the Advanced Toolkit. And at the absolute heart of this toolkit is the Standard Template Library, or the STL. Think of it as a treasure chest of super efficient, ready-to-use code. As you can see, a huge part of it is made up of something called containers, which, as the name suggests, are all about storing and managing data.
So what does this actually mean for you? It means you don't have to waste time building complex data structures from the ground up. Need a list that can automatically grow as you add more items? Use a vector. Need to store information like a dictionary with a key and a value? Use a map. The SCL gives you these professional-grade tools right out of the box, saving you an incredible amount of time and letting you focus on solving your actual problem.
And there you have it. That's the whole journey, right there. We started with the simple grammar of syntax and variables, we moved on to controlling our program's logic, then organizing everything with functions and structures, all the way up to the powerful paradigm of object-oriented programming and the pro-level tools in the STL.
So that's the roadmap. We've seen how these simple ideas build on each other, from basic building blocks to reusable functions, then to powerful objects, all accelerated by advanced toolkits. You've seen the map of the territory. The only question left is, what are you going to build?